Welcome to Tutors. Once again, it's a right. So we're going to do quotient rule. Quotient. And personally, if you heard of the word quotient, like those are familiar with the word quotient, you know it's more about division. Okay. So quotient rule is a rule that governs divisions of functions. Okay, and the way to go about it, an easier way, a simplified way, better. Okay. If y is equals to two functions dividing each other, where the upper function is named u and the down function, the denominator, is called v. Okay, our dy dx will be giving us v multiplied by what? Du dx minus u dv dx over v squared. Now there's something I want you to take from this, is that for your product rule, your V, your V is your V can actually start. You can start like with V du dx plus U dv dx, but I still follow the method. Product rule starts with U, then V. But quotient rule, that must always start with V. Remember, write somewhere. Quotient rule always starts with what? V. Quotient rule always starts with what? V. Good. Quotient rule always starts with V. So v du dx minus u dv dx. You will get a wrong answer. You start with u. Okay. But anyone that you use, just make sure you are consistent. Okay. Like I'm talking about for product rule. Because product rule, what is connecting them is a negative sign. For product rule is a positive sign, I mean. Okay. But quotient rule, the negative sign. So you cannot bring u first and bring v after and say you get the same thing. But product rule, you can interchange them since both of them are combined together with a positive sign. Okay. So, but let's just move on. Yours is just for you to know the formula. Okay. And don't try to tweak it. Good. So, first question. Given that y is equals to ln x over x, given that y is equals to ln x over x, find dy dx. Okay, so we say let u is equals to ln x and v is equals to x. So we say du dx is equals to what? 1 over x. So that's the differentiation of ln x is 1 over x. And the differentiation of v. V is x, have it? You know how to differentiate a polynomial. So differentiation of a polynomial or algebra, I did that in the power rule in the first video. Okay, 1 times x is x raised by 1 minus 1, and 1 minus 1 is what? 0. X raised by 0 is what? 1. So we have dv dx is equals to 1. Good. So let's substitute our answers. So the first thing in our formula is v times u. What's our v here? Our v is here. V equals to x, right? V, okay, times du dx. What's our du dx? 1 over x minus u. Our u is ln x times what? 1 over v squared. What's our v? X. So x squared. X can cancel x. We have 1. 1 times 1 is what? 1. Minus ln x times 1 is also what? Ln x, right? Over x squared. Final answer. Okay. Now, next, by 2, y is equals to tan x. Now, recall that um, when I was differentiating tan x in the product rule video, I made mention of that the differentiation of tan x is sec square x. Okay, so what? Why I'm mentioning y equals tan x in a quotient rule example is that tan x can also be expressed as what? Sine x over what? Cos x. Okay, sin x over cos x. So that's an expression from our Pythagoras and our trigonometry. Okay, good. So let's differentiate sin x over cos x. So we say let u, so we're told to find dy dx, right? Question mark. U is equals to sin x and v is equals to what? Cos x. Okay, let's start from here. Use sin x, v is cos x, use sin x, and v is cos x. Good. So for me, I will give in that if he is giving us sin x and v is cos x, and we try to differentiate du dx, we'll get cos x, abi? If it's sin x, we get cos x. And differentiate dv dx, you get what? Minus sin what? X. Okay, good. So let's substitute our value inside our dy dx formula for quotient rule, which is given as v multiplied by what? Du dx minus u multiplied by dv dx over v squared. So v, where's our v? Cos x, have we? Cos x times du dx, which is what? V du dx. Our du dx is what? Cos x minus u, which is sin x, multiplied by what? Minus sin x. Everything over what? V square. What's our v square? Cos x all what? Square. Okay. What is cos x times cos x? That's what? Cos x all square, abi? And that's cos square x. This is how it's written in cos x all square is written as cos square x. Okay. Minus, then here becomes what? Minus sine square x. Okay. Over what? Cos square x. Good. Now, continuing from that, we see that dy dx now becomes cos square x plus sine square x over cos square x. Good. Recall from trigonometry identities. Okay, trigonometric identities, that cos square x plus sine square x is equals to what? 1. Is equals to 1. Okay, and 1 over cos is equals to sec x. Okay, so dy dx will now become what? So we have cos square x plus sine square x, and in this way we say cos square x plus sine square x is equals to 1. So here becomes what? Our numerator becomes what? 1, have you? So our denominator becomes what? Cos square x. But from trig identity, we also know that what? 1 over cos x is also equals to what? Sec x. So 1 over cos square x will be equals to what? Sec square x. That is why the differentiation of tan x will be equals to what? Sec square x. Okay, that's a nice example on quotient rule. Okay, so we'll finalize by giving you guys a work to do, and make sure you comment the answers in the comment section. So given that, find dy dx, find dy dx, our work to do, find dy dx when y is equals to cot x. Okay, let me give you an hint here. Cot is like the inverse of tan, which is cos x over sin x. So if y is equals to ln x over x cubed, 3, if y is equals to cos x over sin x. Okay, so get all of the derivative of the following function and continue solving and keep solving and you keep improving in your calculus journey. Thank you for the ride in our special function journey. Thank you. The next video will be on simplifying functions and standard differential tables. Thank you very much.